Right now, at this very moment, something from beyond our solar system is racing through our cosmic neighborhood. And what it just did near the sun has scientists asking a question they rarely ask out loud. Could this be artificial? This is 3I Atlas, the third interstellar visitor we've ever confirmed. And here's what makes this different from anything we've seen before. This object just executed a precision course correction that will place it at the exact edge of Jupiter's gravitational sphere next March. The mathematical precision required for that? It's the kind of accuracy you'd expect from a spacecraft, not a comet. Before we dive into why that matters, subscribe to Space Aquarius and tell me in the comments what country you're watching from. I love knowing we've got people all over this planet watching the same cosmic mystery unfold together. Now let me show you exactly what's been happening. Because to understand why that Jupiter trajectory is so extraordinary, you first need to see the 12 other anomalies that came before it. July 1st, 2025. That's when astronomers first spotted 3I Atlas entering our solar system. And right from the start, something was off. The first red flag? Size. Early estimates put 3I Atlas somewhere between 3 and 6 miles across. The evidence increasingly points towards 6 miles. That makes it 20 times larger than Oumuamua and 10 times larger than Borisov. Now, here's why that matters. For an object that massive to survive billions of years traveling through interstellar space, dodging stars, avoiding collisions, surviving gravitational encounters, the odds are already incredibly low. But then for it to arrive at our solar system at the exact moment in human history, when we have the technology to observe it, that's pushing coincidence into the realm of the extraordinary. But size alone doesn't make something suspicious. What makes 3I Atlas truly bizarre is what it did when it got close to the sun. And to understand that, you need to know about the timing. 3I Atlas didn't just randomly show up. It arrived during 2025, a solar maximum year. That's when our sun hits peak activity in its 11-year cycle. During solar maximum, the sun becomes violent. Its surface erupts with massive storms, producing solar flares and coronal mass ejections, huge chunks of the sun's atmosphere blasted into space. You've probably seen the news about those spectacular auroras lighting up skies all over the world this year. That's what happens when the sun's ejected material slams into Earth's atmosphere. 3I Atlas flew straight into that chaos. On October 29th, it reached Perihelion, the closest point to the sun. This is the moment of truth for any comet. The sun's energy forces it to react, to reveal what it's really made of. And 3I Atlas? It reacted in ways no comet ever has. Now, getting a clear image of 3I Atlas before perihelion was tough because of the distance. NASA did manage to capture one photo using a satellite orbiting Mars, the sharpest image we'll ever get. The result? A fuzzy white blob. Disappointing. But here's where it gets interesting. You've probably heard we couldn't observe 3I Atlas as it flew past the sun, because Earth was on the wrong side of the solar system. That's mostly true, but we had a workaround. Two satellites, America's GOES and Europe's SOHO, carry special coronagraph telescopes. These instruments use a simple but clever trick. They block out the sun's overwhelming brightness with a disk, allowing you to see the corona, the atmosphere around the star. These coronagraphs are designed to monitor solar weather, but they also let us observe objects near the sun that would otherwise be invisible. And what they captured during 3I Atlas's perihelion passage. That's where the anomalies start stacking up. Anomaly number 1, the brightness explosion. As 3I Atlas approached the sun, its brightness increased. Objects get brighter when they get closer to light sources, except 3I Atlas didn't just brighten, it exploded to 400 times its previous luminosity in just days. A typical comet might brighten by 10 to 100 times during perihelion. 3I Atlas blew past that by a massive margin. Anomaly number 2 and number 3, the impossible color changes. When we first observed 3I Atlas in summer, it reflected mostly red light. Normal for a comet, they're surrounded by dusty atmospheres that reflect red. Then in September, without warning, it turned green. Scientists still can't fully explain why. But here's where it gets truly strange. As it got closer to the sun, it changed again from green to blue. Now, if you know anything about light and heat, you know that's backwards. Comets approaching the sun should shift toward red, not away from it. Look at a color spectrum. Green sits in the middle. Blue is on the opposite end from red. For 3I Atlas to go from green to blue means it moved in the wrong direction for a natural comet. There are only two natural explanations. Either it released some bizarre type of bright blue gas we've never seen before, or it was breaking apart under the sun's stress. But we know it didn't break apart. We've seen it intact after perihelion. So what's the third explanation? That's where things get uncomfortable. Anomaly number 4, the course correction. Right after that blue flash, 3I Atlas did something that made every astronomer watching lean forward in their chairs. It changed course. Now, comets can naturally show some course changes during perihelion. Gas venting from the surface acts like tiny thrusters, pushing them around a bit. That's normal, but here's what makes 3I Atlas different, and this is crucial to understanding the Jupiter connection. For its entire journey through our solar system, months of observation, 3I Atlas showed almost zero course deviation. It traveled in an incredibly straight line. Most comets wobble. They release gas unevenly, they drift. But 3I Atlas? Laser straight for months. Then, on October 29th, the exact day of closest approach, it suddenly demonstrated the most powerful non-gravitational acceleration ever recorded for a comet-like object. The measurements? It shifted 84 miles perpendicular to the Sun, while simultaneously accelerating 37 miles along its path. That's about 124 miles of course change per day. Compare that to Borisov, our best reference for an interstellar comet, which showed about 62 miles per day. Half of what 3I Atlas did. Or look at Hale-Bopp, a famous comet with powerful outgassing. It only showed about 1% of the acceleration we measured from 3I Atlas. So we have an object that held a perfectly straight line for months, then executed the most powerful course change on record, precisely at its closest point to the Sun. And here's the critical question. Why then? Why there? Hold that thought, because what happened next makes it even stranger. Anomalies number 5 to 7, the 7 jets. On November 8th, just days after perihelion, images revealed something unprecedented. 7 distinct jets of gas erupting from 3I Atlas's core. Most pointed away from the Sun normal, but a couple aimed directly toward the Sun not normal. Here's the problem. 3I Atlas rotates once every 16 hours. If these were random gas emissions, that rotation should smear them into one blurry tail, like we see on normal comets. But these jets stayed distinct, separate, powerful enough to maintain their individual structure despite the rotation. Then, just 24 hours later, everything changed. Those 7 jets merged into one massive plume, stretching nearly 1.9 million miles into space. But, and this is anomaly number 8, there was a second plume, an anti-tail extending about 620,000 miles in the opposite direction, toward the Sun. Anti-tails are rare. The solar wind should push everything away from the Sun, especially this close in. Yet 3I Atlas was generating a massive Sun-facing emission anyway. That's not how natural comets behave. The solar wind doesn't work that way. Anomaly number 9, the impossible mass. The fact that 3I Atlas ejected millions of miles of gas and dust yet stayed intact tells us something crucial. This object is extraordinarily massive. Given what we've observed, the larger size estimates seem most likely, around 6 miles across. That's 20 times larger than Oumuamua and 10 times larger than Borisov. Think about the probability. Something this big surviving billions of years in interstellar space? Already unlikely. Arriving at our solar system when we can observe it? Even more unlikely, but here's where it all comes together. Anomaly number 10 to 12. The trajectory, the timing, the target. Scientists at NASA have been tracking 3I Atlas using data from about 230 observatories worldwide. They've calculated its complete trajectory, including that burst of acceleration at perihelion, and that's when Harvard astrophysicist Avi Loeb noticed something extraordinary. He asked a hypothetical question. If you wanted to place devices in orbit around Jupiter, what's the farthest distance you could arrive from the planet and still succeed? The answer is Jupiter's Hill radius, the precise boundary where Jupiter's gravity becomes stronger than the Sun's. Inside that radius, Jupiter can capture and hold objects in orbit. For Jupiter, that radius is mathematically exact. It's calculable down to the mile. NASA's calculations show that on March 16, 2026, 3I Atlas will reach its closest approach to Jupiter. The distance? Exactly Jupiter's Hill radius. Anomaly number 13, the precision. Here's what Loeb pointed out, and this is the part that changes everything. That burst of non-gravitational acceleration at Perihelion, the one that happened on October 29th, was precisely the amount needed to adjust 3I Atlas's trajectory to arrive at Jupiter's Hill radius. Without that course correction, it would have missed that boundary. But with it, it arrives exactly where it needs to be. Let me say that again. An object traveled in a straight line for months through our solar system. Then, at its closest point to the Sun, it executed a course correction of exactly the magnitude required to place it at the optimal distance from Jupiter for deploying objects into orbit. The level of precision required for that is extraordinary. It's the kind of accuracy you'd expect from mission control at NASA, not from a natural comet venting gas randomly. So let's connect all the pieces. We have an object that's 20 times larger than any previous interstellar visitor. It arrived during solar maximum, the most energetic period of the Sun's cycle. It changed color twice in ways that defy normal comet behavior. It held a perfectly straight trajectory for months, then executed the most powerful course correction ever recorded, precisely when and where it needed to. It produced 7 distinct jets that resisted rotational blurring. It generated a massive anti-tail that defied solar wind physics. And that course correction will deliver it to Jupiter's Hill radius with mathematical precision. That's 13 documented anomalies. 13 behaviors that don't match natural comets. Does this prove 3I Atlas is artificial? No. Science demands extraordinary evidence for extraordinary claims. But it means we need to watch very carefully over the next few months. The Juno spacecraft is currently orbiting Jupiter. If 3I Atlas deploys any objects that begin orbiting Jupiter that we didn't send, Juno will detect them. And if we find technological satellites around Jupiter that humanity didn't place there, that would be the most significant discovery in human history. There's also December 19th, 2025, when 3I Atlas makes its closest approach to Earth. Every major telescope will be watching. Loeb noted something poignant. Not finding similar devices near Earth might suggest our interstellar guest isn't interested in us. We're not at the center of the solar system, and we're not at the center of attention of our cosmic neighborhood. As he put it, it's like attending a party where nobody wants to dance with us. Perhaps the human species arrived late to the party. If this breakdown got you thinking about what's really happening in our solar system, I need your help. YouTube just launched a hype feature that super boosts videos in their first 24 hours. If you found this valuable, hit that hype button right now. Subscribe to Space Aquarius because we're tracking 3I Atlas through its December Earth flyby and March Jupiter encounter. You won't want to miss what happens next. Leave a comment with 2 things. First, what do you think unusual comet or something more? Second, what country are you watching from? I'm genuinely curious where everyone's located as we watch this cosmic mystery unfold together, and share this video with someone who appreciates real space science backed by actual data. This story deserves to be discussed.